welcome to all the participants. I'm sure that with most of you, we spent a couple of hours yesterday afternoon, so no need for introduction on my side. I believe what Kati started to say was that yesterday we had a pretty positive afternoon with the introduction from the partners in the program, from Yavede, from Walter, from Phil, from the World Bank colleagues. Raymond spoke a bit, and the corporate partners, the academic partners, Sofia University. So I think there was a general feeling and appreciation yesterday that this group of around 50 people that we got together yesterday is a good illustration of what we want to achieve as a community of water practice. Today we are going to spend the next 2 hours and a bit in the details of the remaining 5 modules. A bit more technical than yesterday, I have to say, after we covered commercial, organizational, and financial topics yesterday. So today I think we'll dip into the very technical, technological, and operations areas of utility management. We are going to have 20 minutes on network operations in a minute. Then we are going to cover the energy topic, energy efficiency, energy management. Then we'll move to plant management, and then after a short break, we'll go into utility economics and regulation, and we'll finish with water safety planning, following the sequence in which the modules will come under the program in the next 2 years, year and a half, 2 years. So thank you all. I already see that we have a group of almost 30 people. Looking at the list of attendees, I think almost all, with a couple of exceptions, the people who will join the program later in June are around. And without wasting more time on introduction, I will move to our first module, which will be the network operations. Our competence partner here is Cubicle, so in a minute I will give the floor to Dobromir Moldovanov, whom some of you know, the guy who is behind Cubicle, the conceptualizer and operations manager of this company. Basically, the idea of this module is, that's quite a central module, I have to say, and it's one in which we will explore in detail the various aspects of network operations, and a very big, very central topic which we want to put on the table is that network operations is not non-revenue water only, at least. Network operations has a lot of things. It has network assets, it has network management, it has monitoring, zoning, preventative, proactive management, etc. Some of these topics we have asked Dobry to briefly present today, so that should give you a feeling of at least some of the key concepts and subtopics of network operations. So for the next 15 minutes plus minus, Dobry, the floor is yours. Thank you.
Thanks, Rado. Hello, everyone. My name is Dobromir Moldovanov. I'm a water supply and sewerage engineer with master degree from the University of Architecture, Civil Engineering, and Geodesy in Sofia. And in last 11 years, I'm fully dedicated in the water sector. I'm participating in different projects related with field measurement, water loss reduction, network optimization. I really appreciate that opportunity to participate in the training, and I'm happy that I will have the chance to share my experience with all participants here. All of you, I believe that you're already aware for the program of that module. What I will try to do is to follow it as much as possible. But in addition, I would like to add some crucial subjects which are important for the operation. In last years, network operation subject was reduced mainly to non-revenue water, as Radu mentioned earlier, and to DMA. Definitely those two subjects are important, but they are only parts of overall network operation. I will try not to talk in common general sayings, but to share interesting examples from my experience and today I just want to shortly present two interesting subjects which will be developed during the training. Apart from what is already published in the agenda, I would like to add the following two subjects, which, as I said, I will slightly affect today. First of them, this is monitoring of water sources. From my point of view, from my experience here in our region, this is a crucial subject, and roughly said, if we don't have enough water in the sources, there is nothing to operate. Monitoring of water sources is a crucial subject which is absolutely underestimated in the Southeast Europe. It is a common practice that amount of water captured from water sources is not measured due to different reasons. Some of them like difficult hydraulic conditions, hard exploitation of measuring equipment, even manipulation of water quantities at system inlet for dealing with water losses. As a result, water operators in our region are not able to control water sources. They are not able to predict water crisis. They are not able to adapt their consumption according to trends of availability of fresh water. And here I want to give a fresh example from Bulgaria from last year. It's a district city near Sofia. Pernik. Pernik is the name of the city. The city has own dam filled by 4 water sources. And
Dobry, you may want to share your screen, I presume, or not?
Didn't I?
No, you didn't.
Sorry.
Please. And you can put it on a full screen mode. Yep.
Okay, I will go one slide back. As I said just 5 minutes ago, I will try to follow the initial agenda of the module. But what I want to add is are several important topics which I believe that should be deeply discussed in that module. And the first of those subject is monitoring of water sources. What I started to explain as an example why it is so important to monitor water sources and to control water sources is a fresh example from Bulgaria, district of Pernik. This is a city with this is an area with about 100,000 people population, and last year we had a dramatic water regime there, and people were threatened by complete water stoppage. The only single reason for this is that water operator did not control their water source in a smart way. I'm not saying that if the water operator control the water source in a smarter way, the water crisis wouldn't happen. I'm just saying that they would control the crisis much better, and I'm saying what I'm saying is that the people wouldn't suffer so much if the water operator controlled the source in a better way. I was happy to be apart from the crisis headquarters dealing with that water crisis, and the first thing what we did when we start working on that problem was to set up a system for flow monitoring at the 4 inlets of the dam, which serves that area. And here on that slide, you can see a picture from the time when we were developing monitoring system at one of the inlets. What we have as a result now, 1 year later, in left, you can see a trend with monthly amount of water which is entering that dam from that single inlet. And we have this information available for all 4 water sources of the dam. We have daily trends, we have weekly trends, we have monthly trends, and we have annual reports of what is happening in terms of water inflow in the dam. And now water operator is able to take necessary measures if they see that trend in some of the water sources is affected. They are able to control amount of water which is supplied to the city, and they are aware that they need to search for a reason if they have a reduction in some of the water, abnormal reduction in some of the water source. Other subject which I would like to add in the agenda of the training program is I call it management of key water and wastewater infrastructure. And here what I would like to share with you is that exploitation is not just opening and closing of valves, but and dealing with emergency repairs. Exploitation is provision of conditions for normal operation of overall water supply and sewerage system and its equipment. In that part of the training, I would like to share with you different good practices for management of potable water treatment plants, pumping station, reservoirs, main pipelines, internal distribution systems and networks, sewerage collectors, and wastewater treatment plants. We will talk about different technologies for measurements of key parameters like electricity, flow, pressure, water quality. We will talk about correlation of different data and taking the biggest benefit from those data. And we will talk about different conditions which need to be provided for efficient network management. Today I would just shortly talk about 2 of the subjects of this part of the training. Protection of external pipelines against air and vacuum. This is a completely underestimated subject in our region. Usually air valves are not served, are not selected correctly, and in total they are not installed correctly. Installation of air valves is not a luxury, but it's a mandatory condition for normal operation of external pipelines. And for sure, there are a lot of tools available for from different producers for sizing and selection of places for installation, but no one talks how to install air valves. Here in picture in right, I shared with you just a short information developed by one professor here in Bulgaria, how it is correct to install an air valve to guarantee enough space where air will could be accumulated and after that released. What I'm trying to say is that from one side, presence of installation of air valves is obligatory, but from other side, presence of air valve doesn't mean that the problem with air is solved. Air valve must be sized, not only sized, but also must be installed correctly. And here I want to give a very nice example. As a part of that water crisis, which I was talking about earlier, our government decided to build a new pipeline from Sofia to that city, which were suffering by water shortage. and I was the person responsible for pressure management of that pipeline. It comes for GN600 pipeline with 190 meters difference in elevation. Unfortunately, in that project, we learned in hard way how important is right installation of air valves. On left picture here, you can see how you can see improper installation of air valve, and you can see how this small air valve here is affecting the work of that big equipment here. What I'm trying to explain is that due to the improper installation of a small air valve, the system was not able to release all the pressure collected inside, and we were not able to start GN500 pressure reducing valve for hours. This is a clear example how something small, like an air valve, GN18 in the example, improper installation of something small can affect overall functionality of 20 kilometers of external pipeline with crucial importance for the water supply of overall city. We'll deeply discuss this subject during the training. I just wanted to give an example for such a management of key water infrastructure. Another part of so-called sub-subject of this topic is control of sewage network. This is something again underestimated. In our region, water operators behave that they have an obligation to serve sewerage network, but at the same time, sewerage network needs proactive maintenance in the same way like water supply networks do. Not only this, but in a long term, lack of proactive maintenance significantly increase exploitation cost of wastewater treatment plants. Two interesting subjects here. Higher industrial load is not something bad, and if water operators are able to, because water operators are able to collect money from it, if they are able to detect from where it is coming, and inflow and infiltration are not unsolved problems. What we are lately do here in the region as a company and me as a specialist, we are very active in using portable water quality samplers. We are installing this kind of equipment in the sewage network, and thanks to it, we are able to isolate sections of the network with suspicions of illegal discharge. But this kind of equipment is also giving us the opportunity to analyze infiltration based only not only on flow measurements, but also on water quality in different time intervals. And Radu, here I will stop. I just wanted shortly to present the additional subjects which I want to add in our module, and I hope that during the presentation of the overall module we'll have time to deeply discuss these problems with the participants.
Most definitely. Thank you, Dobry. Thank you. You can unshare your screen. What Dobry made is a very good illustration on how specific, rather technical and operational aspects can have a very deep level on the overall performance. So that's how technical topics become management issues. And this is pretty much the philosophy of our program. Yesterday, I spent some time outlining to all of you that we are targeting wide spectrum of topics, and only where necessary we will explore certain aspects in more detail. And actually, Dobry and Cubicle just demonstrated an example of such topics. We have quite a few financial people, economists, and lawyers in our participants. I hope they don't get lost on some of the slides. But pretty much that's the concept, to make sure that people with non-technical background also get exposed to criticalities on network operations. During this module, which will come in the beginning of 2022, actually, this will be the 4th module in the program. As we told yesterday, we will first cover topics like asset management and financial management, because certain key concepts are going to be then utilized in the rather technical modules. In the deeper preparation for the module, together with Dobry and Cubicle, we will be exploring good practices from Sofia Water, from Winwasser, from Energie AG, from some of the participant companies. I mean, I definitely know that companies like Pristina, like Dures, like Tirana can share some examples, and these are the ones I know. I'm sure that other attendees to the program can offer also good examples. So looking forward to that module. As I just mentioned, it will come in the very beginning of next year. We will do our best to both connect this module to others, like the financial one, like the asset management, but then we will pretty much rely on Dobry to pinpoint the criticalities of the network topic in the way he started to do today. So again, thank you, Dobry. We're looking forward for that. Later in the year, we will introduce you to the participants in the program, and vice versa. I hope the last 20 minutes gave us all a good initial understanding of some key topics of network operations. Thank you again. Without losing more time, I would like to switch to the 2nd module, and here I would invite Albert and Chris to turn on their cameras so you can see their faces. Albert is our key guy for this module. He is representing Econolayer, the competence partner, the technical partner for the energy efficiency program under the Danube Learning Partnership. And it was a very natural thing that we slightly expand this energy efficiency scope into something a bit more wider, a bit more management related, energy management and energy efficiency. Albert, the next 12-15 minutes plus minus are yours before we give the word to Chris as well for a short intro. Okay. Go ahead.
Okay, thank you, Radu. Okay, so my name is Albert Williams. I'm from South Africa, and I'll be responsible for the energy management and energy efficiency module. And yes, energy is the hot topic of the day. And for the next 30 years, it's going to be the hot topic internationally. And yesterday, the International Energy Agency came out with this new report saying that end-use energy efficiency and energy management really is the key aspects in achieving the Paris Agreement, where we need to limit our carbon emissions. So about 40% of achieving that target is going to go to end-use energy efficiency and energy management. And also about half of all the investments in the next 30 years will go into this topic for energy efficiency and energy management. So from the end user side, energy management really is sometimes a overlooked aspect, and people don't realize how attractive investments in energy efficiency is. 8 out of 10 times investment in energy efficiency will outperform investments in, for example, operational expansion or investing in companies. So energy efficiency is extremely attractive out of a financial aspect and also out of an environmental aspect. So just to give you a bit of an overview, globally, electricity is consumed in these areas. And we've got electric motors, that is 40% of all global electricity consumption. Now, if you take that motors and you divide it up into the end-use equipment, pumps are sitting with 22% of that 40% electricity consumption globally. So in comparison with pumps, compressed air, refrigeration compressors, conveyors, hoists, pumps are really the largest of all of these types of equipment. And that's where we will focus on in this energy management water utility aspect. There's some more numbers there that just to show you the global energy consumption, global electricity supply, industrial electricity supply, and motors consume 2/3 of all industrial electricity. And then pumps, as on the previous slide, was 22%. So we're sitting with a massive amount, 1,200 terawatt hours per year globally, which at about 10 US cents, or that's actually euros, 10 euro cents per kilowatt hour. We are investing 150 billion euros per year in operating pumps. That's the cost that's the electricity cost to operate pumps. Now, there was also another study that mentioned that if you go into the average facility, you can save 26% in a financially feasible manner. Now, if we can save all the money in all industries, if you can save 26% on pumps alone, we can access 39 billion euros. So there's a lot of money available, and there's a lot of savings available. So how are we going to get this money? How are we going to achieve these savings? And in this module, we're going to discuss the systems approach. We're not only looking at pumps, we're looking at the entire pump system. So that includes the motor that is driving the pump. Now, if you look at an average motor, you maybe get a 91% efficiency, but there's a drive, like a variable speed drive, that is driving this motor. And the pump has varying ranges of efficiency. It can range between 0 and 85% of efficiency, depending on how it is operated. Now, if you improve the motor, or if you only improve the pump efficiency, you have very limited savings, maybe 3 or 5% efficiency improvements. But we are looking at the entire system. We're looking at the piping, the distribution network. We're looking at how the water is consumed. We're looking at things like control valves or bypass control. So we are really considering everything that has to do with pumping water from one side to the other. And if you do the system efficiency, that's where we get this massive savings, 26% or more. And I'll show you some case studies at the end where we can save 40%, up to 70% savings is possible with this system approach. Another way to look at the systems approach is to see that, pumps, in this example, pump has got an efficiency of 77%. We've got a motor, we've got a drive or a transmission. But here we're sitting with a control valve, and we are losing a lot of energy in that control valve. So in this top picture here, we are getting a system efficiency of, we're only getting 31 units out for every 100 units we're putting in. So we have a system efficiency of 31%. Now, if we do a systems approach and we take out that throttle valve and we look at how the pump is operating to only supply what is required, we can actually improve the system efficiency to 72% from 31. It's more than a double amount of savings. So we're still getting 31 units out, but our input energy goes from 100 units, it goes down to 43 units. So we need a lot less electricity to run an optimized system. And that energy that's been made available can now be used for other things. It's a virtual power station. You have created a virtual power station, and we can use this freed energy to basically improve the economy. With regards to the technical aspects of pump systems, we're not going to discuss this too much now, but pumps are used to move liquids or slurries in some aspects. Now, there's three things that's important here, and we'll discuss this in the module, but static head and friction head, and velocity head also, but static and frictional head or losses. That's the most important aspects. And we're going to spend a lot of time in the training course to determine these things. How does it work? For your specific situation, how much static head and frictional head do you have in your system? So a pump is basically a machine that is used to overcome these losses. Now, just to give you a bit of an overview, when we are going to look at the frictional head, we're going to do some technical analysis. We're going to use some diagrams such as this. We're going to use some formulas. And step by step, we're going to look at all of these aspects, how to determine that. And it's not so that it looks complicated now, but if we go through it step by step in a sequential way, it's actually quite nice to see how much energy you are losing in your system and how to overcome those losses. We use that energy, that head requirements, and then we take that to a performance curve. Now, these pumps have performance curves, and there's also a system curve. We're going to use that head requirements to draw a system curve. Basically, we use this information to understand where the pump is operating and what can we do about that operating point. Can we change that in a more efficient way? And a lot of time, it's a very cheap saving. Sometimes it's a zero investment cost to improve a pump's efficiency or a pump's system efficiency. In addition to energy and energy savings, we also look at maintenance, because maintenance and energy has got a very much interlink. If your pump is operating incorrectly, you get all sorts of problems with these impellers. We call this cavitation, which is very common. Now, what is causing cavitation? How can we solve this? Things like your shaft alignment. We're going to look at that. Your bearings, heat, and how that has influence on your motor. And we are trying to keep the pump operating in a certain efficient way so that we do not have these maintenance aspects or these breakages that happen. That is a big headache in most pump systems. So in our module, we're also going to go into the field. We're going to take some equipment, some measurement equipment to measure pressure, flow. In this picture on the right, we are measuring the kilowatt power that is feeding into the motor. So we use all of these parameters to determine what is the kilowatt requirement of this pump and what is the system requirement of this pump. So we need to have data so that we understand what's happening and how to improve the system. So it's quite a fun exercise to go out in the facility. We then take all of this information and we put it into some software tools. And there's various types of tools. We're going to probably use Red Screen, and we're going to go into some detail there. There's also other tools like Measure, which is free software to a certain extent. We're going to use this software. We're going to plug it in with the data we captured on the facility, and the software will assist us to quantify the possible opportunities and how much money we can save and how can we improve the system. So just to close off, just quickly going through some case studies. We don't have a lot of time to go through everything, but just 3 case studies where I was involved in personally. The first one is in Egypt. They had some nice sized pumps there. And we found that the control valve was 40% closed, 60% open. We found some leaks in the system, and these pumps were very old, 50, 60 years old. So we looked at these things, we improved those situations, and at the end of the day, what we did is to determine what is the amount of water that is required by the system, and we only supply that requirement in the most efficient way. So there's just a bit of the business case, the cost and the savings involved, but in this facility, 3.4 gigawatt hours per year, or 121,000 euros of savings was achievable. Another one was from South Africa, where we looked at 315 kilowatt pumps. Only one pump was operational, only one pump. And we looked at the suction conditions of this pump, how to improve that, looking at the piping, looking at the suction tank or the feeding tank. And we saved 19% by doing very low cost interventions. We saved 100,000 euros on one relatively small pump. we also improved the maintenance. We reduced the maintenance by getting rid of this cavitation effects. And then the last one was from Albania, where we had 4 pumps, actually only 2 pumps operational, about 300 kilowatts, 4 gigawatt hour per year baseline. And we looked at what's happening inside of the pump room. We found all sorts of restrictions and losses. We looked at how the pumps are controlled. We found once again a discharge valve that was closed, relatively closed, and a variable speed drive was not used properly. And by reconfiguring these things, by upgrading the motor to a more efficient motor and to manage the leakages, we were actually able to save 42% of the energy at a cost saving of 240,000 euros. It's extremely attractive project. The simple payback in this case was only 0.1 year. So most of the time, as I've said, investments are very low cost and very easy to achieve. So I'm looking forward to these modules. We're going to go into a lot of detail. And yes, I hope to see you soon in person. And I think you're going to enjoy this module. Okay. Thank you, Radu.
Albert. Not so soon, to be honest. It's scheduled for next year, but at least some preparatory webinars, we can see each other. Thanks a lot. I would, in addition to the technical and operational side of the things which you just presented, I would like to give the floor for a brief intro from Christopher from the World Bank, so he can provide a different perspective to this high priority topic of energy efficiency. So the floor is yours, Chris, for a short intro.
Thank you so much, Rado, and thank you for giving me the opportunity. This was a very intriguing presentation for me. So I am a senior water and sanitation specialist with the World Bank. I've spent about 10 years in Africa on rural water supply, and now the last 5 years I've been in Washington. I'm the coordinator for energy efficiency in the water sector in the World Bank, which sounds very glamorous maybe, but it's not, because it's a completely overlooked area. And actually nobody has been paying attention to it. Haven't gotten any budget for it. Our various lending programs in many countries have not paid much attention to energy efficiency. But recently, this whole talk about the Paris Agreement, the US signing in on it, more focus on mitigation. I think that suddenly, there's just over the last couple of months, I've seen a huge fluctuation in interest in energy efficiency. So my job, actually, I'm learning a lot from this presentation, because my job is not to provide this kind of knowledge. I'm not a technical person per se, but my job is to try to think about how we solve this issue at scale. Knowing with all the issues the water utilities have, how do we solve this in a very efficient way, in a very short-term way at scale? So let me just, give you my view on this. So maybe like 7 years ago, I was in Tanzania, and there was this little town, maybe 40,000 people, and I learned that they had 3 pumps, which I thought was okay, they were pumping for a reservoir. But then I learned that those pumps were 300 kilowatt pumps for that little town. And it surprised me. I couldn't believe the amount of energy that little utility was using. And that was the first time in my career where I thought, wow, energy for water utilities, wastewater utilities really matter. Then a few years later, not paying attention to energy efficiency at all, I went to Panama for a completely different topic. And they have one national water utility in Panama. And I learned that national water utility was the largest consumer of energy in Panama, in the entire country. I thought that was interesting. I started to do a little bit on energy efficiency. And recently I learned that in Ethiopia, the capital Addis, 30% of the city's energy consumption is used by the water utility. And very recently, I'm working on a project with a colleague in Mexico City, where they have a pumping operation in Mexico City that uses $130 million per year. And another project, we are working with the Manila Water in the Philippines. Manila Water are customers of 6 million people, they have not conducted a comprehensive water audit for the last decade. Nobody in the utility can remember the last time they did a proper energy audit. So I think that just, you know, those few anecdotes just tells us, or tells me at least, that this is a hugely overlooked area. And as the colleague from Condelaire pointed out, it's incredible when you look at the return on investment. I've seen in Tanzania some capacitors, the return on investment was 2 to 3 months, and you just saw here it was somewhat the same. And I think most, as we see it through the energy audits and investments we have done, the typical return on investment, the payback period, is between 2 to 5 years. So there is a really ripe opportunity for energy investments in energy efficiency. So one could wonder why, I mean, if they have these enormous, you know, returns on investment and the technology is there, why are utilities not investing? And of course, we all know this, some utilities are not paying their own electricity bill. Some utilities have really strained on their cash flow and cannot afford to invest. So we have very, very intensive pumping operation, very inefficient, and we have all the technology just waiting to be adopted. Especially the recent years, I mean, there's so much more than pump replacement, variable speed drive that can be done. It's getting quite advanced, and I think the savings we're seeing in some utilities is beyond 50%. Of course, it varies from utility to utility. So what we are trying to do now, actually in Eastern Europe, with Radar and the team, is to think about how do we address this large scale? How do we bring somebody like Colère from Canada to address this issue? How can utilities leverage this, you know, world-class expertise that Siemens, Grundfos, and some of these consultancies they have? Right now, we are thinking there's no way that we can expect urban water utilities, large urban water utilities, to be experts in these fields. There's no way we can expect them to understand what is the newest technology. And there is very little leg room for investing in energy efficiency. So what we are doing right now is to start to think, and Radar is helping me a lot on this, to think of a system where we have an ESCO type approach, where an energy service company like group from the private sector comes in, provides their own financing, and invest in energy efficiency at an urban water utility. And then it's sort of the shared cost model where the private sector makes the investment, and then the energy savings are shared between the companies that invest and the urban water and the utility over a number of years. So that is a model we believe could really work, especially in Eastern Europe. And we are very interested in discussing the opportunities and the challenges of this model. We are working with the World Bank private financing lending arm, IFC, that lends to private companies. And we are talking to partial risk guarantees to try to create a financing mechanism where the private sector can come in and we can gain all the good expertise, advanced technologies, and then the utility can get a hold of that, and the cost can be shared between the utility and the private investor. So that's, you know, what we are thinking right now. I hope within the next couple of months we will be able to reach out to you more directly to have a dialogue about that. So we are very excited about energy efficiency. I'm very happy to see the presentation which was just made. So thank you very much.
Thanks a lot, Chris. Thanks a lot for giving the perspective of the financial institutions and for declaring your commitment to be part of this dialogue between water utilities, problem solvers, private sector, but not only, and financial institutions. This is definitely something that we are going to target around the module. It's not by chance that yesterday we opened the discussion by declaring that by far the biggest purpose of this program is to create a dialogue and a community of practice, how we call it, something that Phil and Katya talked about yesterday. So I think your involvement today demonstrated that. Later today, we're going to have another guy from the bank, Ivailo Kolev. So I think it would be good that at the end of these 3 days, we're going to make sure at least some initial connections have been mapped out for a further discussion. Thanks again, both to you, Chris, and to Albert. It's a very technical slot of a couple of modules. We had the networks earlier today, then we had the energy efficiency. I think one of the big challenges in front of this program is to identify the minimum level of necessary knowledge on technical topics that non-technical managers should have. I think with the Moore's graph, Albert, you went a bit too far. So did Dobry earlier today on sizing of air release valves. But I hope that Dobry Simichev and Rado Zlatkov in a minute will not go that much or even more deeply into plant operations, which is another heavy technical and heavy operational area. With that, I would like to move to this third module for today and sixth module overall, plant operations. I would invite Dobry and Rado to switch on their cameras. I will properly introduce them as people with whom I've got no formalities whatsoever, to put it mildly. We've been colleagues together for many, many years in Sofia Water. And some years ago, I had the pleasure and honor to join them in founding the company that they represent today. And throughout this module, for the plant operations, we're going to have Hydrolia as a competence partner, a company that operates primarily industrial water and sanitation assets, which means a lot of focus on wastewater and potable water treatment plant, but wastewater is actually the focus. Dobry and Rado will talk a bit more about that. Just a couple of words from me on the module in overall. This module will be sometime next year. All of you have the link to the program, so it's third quarter or between second and third quarter next year. Unfortunately, because we want to squeeze everything in the UMT, we decided to combine both potable and wastewater treatment plants in one module, in a module that will cover operations, process, technologies, regulations, and a bit more financial, organizational, and management topics. I hope Dobry and Rado will give us just a bit of a glimpse of what some key aspects of that are today. Let me stop here. I'd like to pass the floor to the two of them. So, Dobry, your turn. Thank you.
Thank you, Rado. It'll be challenging to squeeze everything in 15 minutes, something that we have been doing for our whole life, basically. But we will try to be time conscious. Now, we've put together a presentation, which I'm going to share now. Is it working?
Yes, go ahead.
Great. So we use the master slides of the entire event presentation. So this is the module that we are going to talk about, plant management. This is the original slide from your presentation, Rado. Now, probably it's worth mentioning a few words about us, and I guess you'll give some sort of answer why are we taking part in the whole in this whole thing. So we are a Bulgarian operation and maintenance company, but also engineering company, which means we are implementing engineering projects. We are focused primarily, if not exclusively, on the industrial sector. But our entire professional background basically was in the municipal sector, so we know both sectors now quite well. We have full national coverage, as we were joking some hour and a half ago. three of us, although in Bulgaria, we basically are in the three different parts of the country as we speak. Actually, more than 50%, the next bullet, more than 50% of our revenues are generated from operations of mostly of wastewater treatment plants. So this is our core business anyway. So I mean, we are more than happy to share part of the experience that we gained throughout the years in the forthcoming modules. Our approach is we would like to be as comprehensive and long-term as possible. And I think it is, because we have more and more projects where we start from basically defining the problem, going through visibility studies, design, installation and construction, commissioning process, and then operations. This is more and more becoming sort of our business as usual model. Currently, we have contractually about 30 wastewater treatment plants for operation. Actually, both me and Radu, we are at two different locations of wastewater treatment plants that we operate with our own staff here all the time on site 24/7. As we say amongst us, we do nothing outside the water, but everything inside the water. So that's our expertise. Now, as I said, it'll be really challenging to squeeze everything about plants, especially having in mind that we are talking about both potable wastewater treatment plants, but still we'll try to do that as a very high strategic level of details. Now, first of all, what is key here is to identify what type of a plant it is. Water or wastewater, this is quite clear. The size matters a lot. Different sizes of plants require different mode of operations, different mode of maintenance, different mode of attitude as a whole. Also, whether it is treating industrial or domestic wastewaters or combined, this is rather different, not only because of different technologies, but also of the different profile of the both quantity and quality of the wastewaters. Normally, the industrial wastewaters, wastewater treatment plants are related with, they are characterized with very unlogical, sometimes very big fluctuations in both quantity and quality. This is not the case for the domestic, so different approach is needed here. Also, treatment technology. Operation depends vastly on the treatment technology, whether it's anaerobic or aerobic treatments, whether it's biofilters or activated sludge, whether it's submerged biofilters or MBBR. There are a series of different technologies suitable for different solutions, but also with the difference in their modes of operations. Also, it is quite crucial, the approach based on whether there is on-site personnel, whether it could be only during the business hours or 24/7, or the plant is maybe smaller or maybe fully automated. Also, the approach is different, and we'll be talking about that later during the training sessions. Also, whether we have remote monitoring and control. It also affects all the decisions that you need to take in relation to the maintenance and operations. And also some local conditions and local specific, all these matters. Of course, the key thing here is the costs, OPEX and CAPEX, both. This is, you know, for those type of trainings, which we are talking about now here, where we should focus on operational issues rather than technical and theoretical issues. I think this is a key element which we would like to focus our attentions on. So basically, for the OPEX, the key thing is the structure of the OPEX, whether most of the money goes to the electricity consumption or maintenance, or maybe the sludge utilization, depends on the type of the plant. And then prioritize your measures based on that. For the CAPEX, the drivers in the CAPEX are, I have some sort of 4 main categories, and whatever you do, you may sort of allocate your CAPEX to one of those. This is simply for keeping it running. So this is asset integrity sort of a driver. Then contractual requirements, then regulation requirements, and then optimization, sort of a business case based solutions. So this is how those OPEX and CAPEX elements should be basically structured and identified. Here I would pass next slide the floor to Rado, who would give his contribution on these key elements.
Hi everyone, my name is Rado Zlatkov, and now, thank you Dobry, I will go through the key factors which we always find every day in our work. As you Dobry said, from the CAPEX and OPEX perspective, it's really related to the key factors, which are the next couple of bullets. Actually, the first bullet is the maintenance, because the maintenance is the, as you said, to keep it running and to not have emergency stops. And this can also make it some issue with the outlet of the wastewater treatment or the treatment of the water itself. So planned versus emergency based, this is always a really big challenge for the utilities to have a planned maintenance. I mean, to have a regular checks of the pumps, air blowers, and to make sure that they are changing coils, filters, and so on the right time, to not have emergency stops. The next, this will go in deep details about the plant and emergency maintenance. Also, the in-house or to be outsourced. What we found is depend of the size of the utility. Probably is the best thing to discuss here. If it's too small, the utilities probably it could be looked at in the opportunities to be outsourced to some other company which can do the maintenance, because the utility don't have the experience and also the knowledge to maintain all the equipment inside the wastewater or the water treatment plant. As Christopher said before, the previous module, actually the energy management is really important also here, because especially for the wastewater treatment plant, the blowers are actually probably more than 50% of the electricity consumption of the plant. So some implementation in energy management to know how much energy go to the blowers, how you can reduce this consumption of energy, to reduce the amount of the oxygen that it's required if it's bio-basin. This can actually help to reduce the energy consumption a lot, but also this is related to the OPEX, and you reduce the OPEX. But once again, you can do the business case by the CAPEX implementation. So everything is related to each other in the management of the plant. The next thing is the reagent management. Here I can say that usually when the designer do the design of the wastewater treatment plant, he introduces some chemicals to be used in the wastewater treatment plant or the water treatment plant. It's the same everywhere. But in the market, it's really moving faster than our market. And what we found that actually there is a really good chemicals that can be reduced once again to have even more efficient chemicals, but reduce the OPEX as well. So this is one thing that we will try to help you to look at it and to find better chemicals to use in the plants but at the same time, it's not only to be more costly, but actually to save money on the other side. Automation is the biggest topic that we always try to implement. Really, the automation and SCADA implementation in the wastewater treatment plant is really important because you can not only reduce the OPEX and CAPEX and the stops, but also at the same time human errors. What we found is actually that most of the time when let's say some of the parameters of the water are exceeding the limits, are usually by human error. When you do the automation, of course, you have to maintain all the sensors and parameters. Again, this is going to the upper topic, maintenance, but anyway, it can help you to achieve a relationship between the OPEX expenditure and also to achieve the limits into the way to not spending too much money to achieve it. The next topic is the sludge. This is the biggest topic which is coming for all the utilities, but not only the utilities, I mean all the wastewater treatment plants. Also for some of the water treatment plants where we have sludge. There is many technologies in a couple of 20 years developed to incinerate, to dry the sludge, to use it for agriculture and so on. This is one big topic that we can go in details during the training. And of course, regulation, which are different regulation in different countries, but it's important to discuss some of the main regulation, like for the European Union and which are in Bulgaria, but probably we can discuss also for the Balkans, where it's important to go in details for this. I passed through Dobry. I think this is, if you...
I think that's it. I mean, I'll stop the share now. Yeah. So this is basically what we wanted to mention, to outline the key issues which you may bump into during plant operation. So we will speaking about that in details when the training takes place.
Thank you very much, guys. Appreciate it. I'm sure that quite a few of our trainers and participants know you and you know them, although probably you don't see them. But two quick comments I want to make before we conclude. One is that as all the other modules, plant management is a good illustration of how an important topic has many overlaps with other modules, most logical thing, particularly with asset management and finance, I would say. Treatment plants, both potable water and wastewater treatment plants, are a very good example of cost centers. They are physically separate, they are a plant by themselves, they have a very conventional, very generic cost structure, staff, chemicals, energy, whatever, outsourced works, etc. The asset management is a very big topic in our program because water utilities are an asset-intensive type of companies, and plants have a lot of assets. They can be segmented, etc. So basically, my role as a coordinator of this program is to make sure that we get the interlinks between the different modules, and I'm grateful that the two of you presented subtopics in a way that refers to the other modules. The other comment I would like to make, and I would conclude with that, is that probably plant management and particularly wastewater operations is one of the most rapidly changing area of the utility management business, for two reasons. One is the development of technologies. The other one is the regulations. As we speak today, the Urban Wastewater Treatment Directive is under revision. This is an area which IWD is tracking closely and organizing webinars and bringing in knowledgeable speakers from Brussels, etc. So it's quite a topic, treatment plants, both wastewater and not to mention COVID and wastewater surveillance and all the epidemiological surveillance, whatever. I'll stop here. Thanks again to Dobri and Radu for bringing the perspective of a practitioner from both operations and management perspective. When the time approaches for the module itself, all the participants will get much more deeply into the topic. With that, I would announce a short break. Let's make it around 10 minutes, and at 3:20 Central European Time, we will convene again with the two evaluators and the utility economics and regulation topic. Thanks again to all the trainers. In the
Cheers, bye.
Let's reconvene in 10 minutes. And I would remind all of the attendees that whoever has any questions, comments, etc. in the chat panel, you are more than welcome. See you in 10 minutes.